So as we begin this new lesson of geometry, we're going to be talking about quadrilaterals and combining those quadrilaterals with the coordinate plane. And in doing so, we want to understand how are different quadrilaterals defined and related. So a quadrilateral, what is a quadrilateral? Well, it is simply a quadrilateral is a polygon with four sides. We look here, we got 1, 2, 3, 4. A polygon is a closed image, on a plane, two-dimensional plane, and a closed where, we have four, in this case, four vertices where it comes together. So as we look at the different types of quadrilaterals, we have, right here, we have a trapezoid. And looking at a trapezoid, we can quickly identify it because it has one set of, or exactly one pair of parallel opposite sides. So here, this is of course our geometry symbol for parallel. Then we come here and we have a parallelogram, and what we have here is both pairs of opposite sides are parallel. And again, we have this showing that these two sides are parallel. And then, of course, when we have two little marks, that is showing that those two are going to be parallel. And then the third quadrilateral we're looking at quickly is going to be a kite. Now, it has two pairs of congruent sides, but the sides are not parallel. As you can see here, we have this side is going to be congruent to this side, and then the other two sides are going to be congruent to each other. So these are our first three items that we're going to talk about when it comes to quadrilaterals. And again, our trapezoid has exactly one pair of parallel opposite sides. That parallelogram, both pairs of opposite sides are going to be parallel, and then my kite, the adjacent sides are going to be congruent, but opposite sides will not be parallel. So as we move in here, now our parallelogram can further be divided into two different quadrilaterals or subcategories. And what we have is we would have a rectangle. We have a rectangle, and what we know here is that it is a parallelogram with four right angles, right? So let's see here, it's a parallelogram. And I can look at my image and I can say, okay, that's a right angle, that's a right angle, that's a right angle, and that's a right angle. So it's still a parallelogram, so all the things apply as a parallelogram. This side is going to be, opposite sides are going to be parallel. So that still applies, but it just so happens that my vertices or my angles are going to be right angles. And then we encounter the rhombus. So the rhombus is, again, it's a parallelogram, so my opposite sides will be parallel, and then the four sides are all going to be congruent. So as we can see here, all four sides are equal. Now we can further break down or further identify, further define our quadrilaterals. And again, of course, we have a quadrilateral which can be identified as a trapezoid, a parallelogram, or a kite. A parallelogram can further be identified as either a rectangle or a rhombus, and it turns out here that you may recognize this shape. It has all four sides are congruent, all four angles are 90 degrees and congruent, and this turns out that what we have here is we are going to have a square. A square can be it is a rhombus and a rectangle. It just so happens to have again, four right angles and four congruent sides. So there you go, as we identify different characteristics and define different quadrilaterals. And so as we look, let's try to use some of these identifying features to work a problem. So Selma wants to build a garden shaped like a kite. Okay. She has logs for the edging. So the edging would be the perimeter around the garden. And then 3 logs measure 6 feet. 1 measures 9 feet. And then 1 measures 3 feet. Okay. Can Selma build a kite-shaped border with these logs without cutting them? Draw and label a kite. Okay, so let's start by picturing a kite. Okay, so here's my kite, and we said that in our description that the adjacent sides would be congruent to each other, but these sides are not parallel. And think about, what do I have here? My lengths-wise, they said I have 3 logs that measure 6. I have 1 log that measures 9 feet, and then I have 1 log that measures 3 feet. And if I were to move these around a little bit, and I just tried to identify, I could say, well, if 2 of my sides were 6 feet, okay, those would be congruent, and you know, that could be part of my kite. And if I eliminated those, because I've already used them, if I look, the remaining numbers, I have 9 and I have 6 and 3. Well, 6 and 3 are going to be, they will sum or add to be 9. So what I could say is possibly one side could be 9, and then the other side could end up being a 6-foot log and then a 3-foot log. And then that together would make this entire length 9 feet. So we could actually create that kite using the materials that they told me I had available. So there we go. And of course, looking at my characteristics, I have 2 congruent sides, 2 adjacent congruent sides at 6 feet. I have 2 adjacent congruent sides at 9 feet in length. There would be a garden, and of course the inside. You know, if it was garden, it can't be a garden unless you put grass in there, right? So there you go, inside the green area, and then the border around it. As we continue looking at some of these characteristics, let's say right here, the sum of the angle measures of quadrilaterals, okay? The sum of the angle measures of any quadrilateral is, well, if we look, here we have a rectangle, and we said that a rectangle has 4 right angles. And if we add those up, you know, of course, that's 90 degrees, and we have 4 of them, times 4 is going to give me 360 degrees. Well, if a rectangle is a quadrilateral and its sum of its angles measures to 360 degrees, well, we're going to find out that all quadrilaterals, the sum of their interior angles will add to 360 degrees. There you go. Now, we don't know when it comes to a parallelogram. We learned that we don't know what the angle measures are here and here, but what we do know is in a parallelogram, my opposite angles are going to be congruent. Opposite angles in a parallelogram will be congruent. And I do know that if I were to label these and I said, hey, let's call this angle 1, this angle 2, this angle 3, and this angle 4, that those characteristics here, I'm going to have angle 1 plus angle 2 is going to equal 180 degrees. And we can work around the parallelogram, and and so think about it. Angle 1 is this angle, plus angle 2 is this angle, equals 180 degrees. So we can mix and match these congruent angles to find out that, of course, these 2 angles right here will add up to 180. These 2 angles right here would add up to 180, or these 2 angles right here would also add up to 180 degrees. And So there it is. There is that sum theorem, that the quadrilateral angle sum theorem is the sum of the angle measures of a quadrilateral will be, or is equal to, is 360 degrees. So again, if I were to look at this, how could I could say, hey, if I were to try and divide this into two triangles, I know that the angle measures, right, the measurement of angles G, D, and E would all equal 180 degrees. I know that the measurements of this G, E, and F would also equal 180 degrees. So thinking about it, the internal angles here, 180, the internal angles here, 180, and we could combine those and find out that it was going to be 360. We could do some substitution too here, a little bit more mathematical, right? Let's see here. And there you go. We have the measurement of angle 1, 2, and 3 would equal 180 degrees. The measurement of angle 4, 5, and 6 would equal 180 degrees. And then, so if we were to combine all those together, of course, we're going to get 360 degrees. And let's see here. Let's try to do this. If we know that the sum of the sum of the angles of a quadrilateral are going to equal 360 degrees, we want to find the angle measures for this kite. Well, let's see, looking at this kite, I know that angle A plus angle B plus angle C plus angle D equals 360, gosh, that's really sloppy, 360 degrees. If I know that those three angle measurements together equal 360 degrees, what I can do now is I can do some substitution. I know that angle A is equal to this, so I can substitute that value in. And I can say that instead of angle A, I could say that angle A is going to be 4x plus 13 plus angle B is equal to this, so I can say plus angle B is going to be 6x minus 16 plus angle C, right? I can substitute in 3x minus 1 plus angle D is going to be 5x plus 4, and those all together we said will equal 360 degrees. So combine like terms at this point in time. I have x's that I can combine because they're like terms, and it looks like I have 18x. And then when I turn around and I combine my numbers, I have 13 minus 16 is going to give me a negative 3. Negative 3 minus 1 is negative 4. Negative 4 plus 4 is going to give me a 0, so plus 0, or I could just leave that off and say that 18x is equal to 360 degrees. Divide both sides by the coefficient, which is 18, and I find out that x is going to be equal to, x should be equal to 20. Now, if I know x, how can I find out what are my angle measurements? Well, I can go back in and I can substitute those values in. I can say, all right, so angle A, I have 40 times x, which is 20 plus 13, is going to be equal to 93 degrees. When I go to angle B, I am going to have 6 times 20 minus 16 is going to be equal to 120 minus 16. 120 minus 16, which is going to be 104 degrees. Angle C is going to be 3 times 20 minus 1, which is going to be 60 minus 1, which is 59 degrees. And then finally, we have angle D, which is going to be 5 times 20 plus 4, which is going to be 104 degrees, 100 plus 4. And if you notice, well, there's not really a lot to notice here. What happens to my angle measurements? If we added them all up, we have 104 plus 104 plus 93 plus 59, and goodness, I hope those equal 360 degrees. Okay, so there we are. We're using some of those characteristics of a quadrilateral to find and solve a problem. And let's see here. Here's some examples to take away from our assignment today. And so we want to solve problems using these characteristics. So if I were to look at example number 3, it says find the value of x and y. Well, I know that this is a rectangle. I hope you do too, that I have measurements here that are 4 right angles. I do not know that it's a square because look, this side is 10, this side is 18. So they're not congruent, so it's not a square, but it is a rectangle. And I know that with a rectangle, I know that my opposite sides are going to be congruent. So here we go, I know that. And what I can do now is, in order to find that, if this side is equal to this side, then that means that 10 plus 2x is equal to 18. Okay, let's see here. So if I work that out, I have 10 plus 2x is equal to 18. I'm going to use my inverse operations, and I'm going to have 2x is equal to 8, divide both sides by 2, and x is going to be equal to 4. There we go. So I know x is equal to 4. And the other sides I know are congruent, so these two sides right here are going to equal. So I can take 2y plus 4 is equal to 10. I'm going to use my inverse operations to isolate my variable, and that is going to give me 2y, that becomes 0, is equal to 6, divide both sides by the coefficient to isolate y, and y is going to be equal to 3. So there we have it. We were able to use the characteristics of that rectangle to solve for those missing variables. Let's see this next image. It says this figure ABCD is a kite. It says find the value of x and the length of line segment CD. All right, so I've got 2 things to do. I need to find out what x is, and I need to find out what does CD equal. Okay, well, I can tell you that I should know, remember when it comes to a kite, that adjacent sides are congruent, and sure enough, they have it identified here. They have your congruency markers here to show that those are equal. So I know to solve for x, which is right here, I could use this characteristic. So I know that 3x plus 1 is equal to 22. And now I can isolate my variable. So I subtract 1 from both sides, and that will 0 out. So I end up with 3x is equal to 21. Divide by the coefficient, and we find out that x is going to be equal to 7. Okay, so x is equal to 7. If I know that x is equal to 7, I could probably substitute that in there and say, well, 4 times 7 is equal to 28. So the segment AD is actually equal to 28. And if you notice, again, the characteristic is adjacent sides are congruent. This is also equal to 28. So x is equal to 7, and CD is equal to 28. So there you have it. And of course, 28 units. I don't know what unit it is, but I do know it's 28 something. And continuing on, again, there's that kite using our characteristics. Let's see this next example. It says we have a parallelogram. LMNO is a parallelogram with the angle measurement. Angle M is equal to 11x degrees. And, oops, my bad. And angle N is equal to 6x minus 7 degrees. Find x, find the measurement of M, and find the measurement of N. Okay, I like to start with a diagram. It just makes it easier for me. Okay, so I have a parallelogram, and they have given me L, M, N, O. I know that this side is going to be parallel to this side. I know that this side is going to be parallel to this side. And then they said that this angle measurement, angle M, is 11x. And they told me that angle N is 6x minus 7. Well, if you remember, these are going to be parallel lines cut by a transversal, and that I know that this angle plus this angle is going to be equal to 180 degrees. So I know that angle M plus angle N is equal to 180 degrees. So if I do some substitution, I can probably find the value of x. So I would have 11x plus 6x minus 7 equals 180 degrees. Combining my x terms here, I have 17x minus 7 is equal to 180. I'm going to add 7 to both sides to zero that out. 17x is equal to 187, and I'm going to divide both sides by 17, and I hope that x is equal to 11. And yes, x is equal to 11. Sorry, I had a student step in. Okay, so if x is equal to 11, then I can do some substitution, and I know that the measurement of angle M is equal to 11 times x, which is 11 times 11, so that would give me 121 degrees. And then the measurement of angle N is equal to 6 times 11 minus 7, which is going to be 66 minus 7, or 59 degrees. So those are my, there we go. There's angle N, angle M, and x. We were able to identify that and come up with a solution using our parallelogram, and for me it just helps to draw an image. And then finally here for example number 6, it says if the measurement of KLH is 134 degrees, solve for x. Okay, we have to assume this guy is a parallelogram. So if this is a parallelogram, I didn't tell you that, but this is a parallelogram, so we know that these things are equal. And it's telling me that KLH, this entire angle right here, is going to be 134 degrees. So we look at this, and I can tell you some of the things that we have to remember is that if these two lines are parallel, and then I have a cut by a transversal, right, that my opposite interior angles would be congruent. So this angle, 25, this angle is 25 degrees. Parallelogram, of course, my opposite angles are going to be congruent, so I know that this angle over here is going to be 134 degrees. And then if I look at triangle KLH should equal 180 degrees, well, I know that I have angle L plus angle K plus angle H is going to be 180, and I know that L is 134 degrees plus 25 degrees plus angle H is 180. I'm going to go ahead and subtract 159 degrees from both sides, and then I find out that angle H is going to be equal to 21 degrees, because that's what's left. And of course, those are combining to 159 and they zero out. Okay, so I found some characteristics here. I use that and it says solve for x. Goodness. Well, I know that opposite angles, and there could have been a quicker way to do this. I'm just sort of given all the stuff that I can understand. Opposite angles, right? Alternate interior angles are going to be congruent, so I find out that this is 21 degrees also. So I know that if I can substitute those two things together, I know that 4x plus 9 is equal to 21 degrees. So I can solve for x. I can subtract 9 from both sides to isolate my variable. That becomes 0. So I have 4x is equal to 12. Divide both sides by the coefficient, and x is equal to 3. Booyah! Look at that, I found 3. So I'll take it. X is equal to 3, and we were able to find out a whole bunch of stuff just because that was a parallelogram. And again, we were talking about how the characteristics, how do you define quadrilaterals and use those characteristics. And in doing so, work through a couple of problems. And as we move into our assignment, these examples right here are going to help you work through our lesson for the day. So we want to make sure that we come back here and we are reviewing and seeing how did we come across these problems and how were we able to solve them. Again, rectangle using its characteristics, a kite using its characteristics, a parallelogram, we drew it to make it easier to see, and then another parallelogram, of course, using those characteristics that we had previously identified when working with parallel lines and transversals. So we will move on today's lesson for classifying quadrilaterals.